Hello. Okay, I'm on. I wasn't sure what's going on here. But all right, so I'm here to talk a little bit about PCI compliance on AWS and really how you can accomplish a lot of the requirements in a Linux-based environment. So I'm Jesse Angel. I'm the CTO of PaymentSpring, and really kind of building things is kind of what I do. I started off in IT and kind of the operations side. Eventually got a little more into the software, so I kind of got a perspective on both sides. But ultimately, kind of building things is my hobby. So if it's not software or IT infrastructure, it's usually trying to keep my experimental airplane from coming apart. So I'm always building little things for that. So a little bit about PaymentSpring. This will just be brief. So we're a PCI Level 1 compliant gateway that runs entirely on AWS. We started working on it about a couple years ago. We built it in about a year and got it in production on AWS. And a lot of why we were able to do it so quickly, some of it had to do with we have talented engineers, but a lot of it was because AWS simplified a lot of the PCI hassles that we were going to have to deal with. But ultimately, security is kind of what we do, and protecting card numbers is our business. And we know that if we make one mistake, have one incident, that could be kind of a disaster for us. So it's something we're always thinking about. So I'm going to give a little bit of a brief overview on PCI, and then a little bit about why that makes a lot of sense with AWS. And then I'll get into kind of really specific technical examples of how you can meet the requirements in a Linux environment. Might not apply to the Windows guys so much, but the concepts are still there, so we'll see. So the first question I get from a lot of people when we start talking about PCI is, what is PCI, and why do they care about it? And really, PCI, it's pretty simple. The Visa, MasterCard, Discover, they all got together, wrote the standard, and if you're touching credit card numbers in any way, it's something that you're going to have to comply with. The problem with the PCI DSS is it really wasn't written with the cloud in mind. The new one, version 3, is slightly better, but not really. So there's a little bit of translation you have to do when you figure out how to meet the requirements. Then the next thing with PCI when we start talking about it is the question I always hear is, does it matter to you? Because quite frankly, no one wants to deal with it. And if you can convince yourself it doesn't matter to you, you don't. But it really, if you're asking yourself that question, it probably does. So if you're a service provider, or if you have a credit card number ever touch your systems in any way, whether it's in memory for a millisecond, it doesn't matter. It's going to apply to you, and if it's a customer of yours that's sending you the card number for a millisecond, then it's going to put you in the highest bracket of PCI as a service provider. As a merchant, so if you are accepting credit cards on behalf of your company, it doesn't take long before you end up in level 1, so you kind of have to plan for level 1 from the beginning, which is what I'm going to be talking about, is kind of the full PCI DSS and how you comply with that. So when you start thinking about PCI and AWS, the great thing about AWS, and not all of the cloud providers, in fact, pretty much none of them, take compliance as seriously as AWS does, but every service on AWS can be PCI compliant. Amazon's done everything they can do to ensure that that can happen, but it's going to come down to how you implement it and what you do for you to actually be PCI compliant. And the more of their services you utilize, the easier it's going to be, because when you're running on EC2, that's going to be where the most of the work is, and that's kind of what I'll get into later, is how you accomplish that stuff on EC2. So if you're on EC2, we utilize as many services as we can to limit our EC2 usage, because the more you do on EC2, the more you're going to have to deal with, and you'll see that as we keep going. But compliance is not automatic. Just because Amazon services are PCI compliant doesn't mean that you're necessarily going to implement them in a way that is PCI compliant. So you must always really understand all of the requirements and which ones Amazon takes care of, which ones you take care of, and most of them are kind of shared between both of you. The best part about AWS, though, is the kind of the worst requirements, the ones I never want to deal with, are all the physical requirements, which is going to take up a lot of time in your audit, are completely irrelevant if you can keep your entire cardholder data environment within Amazon AWS. So when you start looking at the PCI, at some point, you're going to have to get audited. If you're level 1, which, as I was explaining earlier, you're going to get to really quickly, you're going to have someone come in every year and do this annual report on compliance that you're going to have to provide to all the card brands. The problem with this is you have to find a, there we go. You have to find a QSA that understands Amazon AWS, and that's oftentimes kind of the hardest part. So as we've went through this process, we really try to talk to the QSAs about what we're doing on AWS, and we try to make sure they understand the concepts. A good example of that we kind of always fight with pretty much every QSA is how security groups work, because they're really comfortable with Cisco access lists, not so comfortable with security groups. So before we engage too much with a QSA, we try to get them to understand how our network works in a VPC, and then try to kind of lay out how the security groups is ultimately going to provide the network security that they're used to in kind of a traditional data center environment. This is probably the biggest struggle that you go through when you're going through a report on compliance with an auditor is the security groups. We went as far as to actually write an application that pulls all the APIs and all the security groups and then writes rules that really look like Cisco access lists, just so that the auditors can understand how it works. So hopefully you don't have to do that. And I've had people ask me for that tool before, but it feels wrong to give it to people because it's something that you shouldn't have to go through. But hopefully there's a QSA out here somewhere that understands this that'll come up to me afterwards, and I can point you guys to them. So the next question is, where do you begin with this? And you're here, this is a good start, and I'll kind of walk you through it, but ultimately, there's no shortcut with this. You have to download the PCI DSS. It's available on the internet, and there's a couple hundred or so requirements in there that you're going to end up having to comply with. If you talk to your AWS compliance manager or your AWS account manager, you can ask them for their PCI compliance package, and then they'll send you a bunch of documentation that'll really show which requirements that Amazon is fully responsible for, which ones are kind of in the gray area between you, and which ones are entirely you. So you really want to get that in the beginning so that you can start to lay out how this is going to work. Once you start to get a feel for the PCI, really the entire PCI process, at the end of the day, revolves around the fact that you write policy, and the policy must comply with the PCI DSS and all the requirements. And at that point, you're then going to get audited to ensure that you're operating according to your policy. So the policy part is really where you begin. And before you get the auditors in, you really want to actually audit yourself to ensure you're following the policy that you write. It's surprising how many companies actually don't do that when you talk to the auditors. People spend a lot of money bringing in auditors back again and again and again. Every PCI audit we went through takes about a day and a half. And that's because we prepare all of this in advance. So I'll kind of show you what we do, and it's going to make it a lot easier and save a lot of money because the auditors, they pretty much print money. So they charge a lot. So if you do this right, it's not quite as painful. But the first question I'd ask yourself if you're looking at this is, can you get out of this? Because there's not... If credit card security, if storing credit cards is not your business, it's probably something you don't want to get into. It's going to slow everything you do, from having to write all this policy, comply with it, and then deal with these auditors. It's not something, it's pretty painful. And at the end of the day, you can look at it and be like, okay, well, we're complying with PCI. That means we're building secure applications. And a lot of the requirements really aren't helping you build a secure application. There's other areas you could focus on, at least in my opinion. So really evaluate if that's a good decision. So if you're starting to look at AWS, why does AWS make a lot of sense if you're trying to be PCI compliant? And that really comes down to just the simple fact that the less infrastructure you have to manage, the easier it's going to be for you. The more infrastructure you have, the more painful the audit's going to be, the more stuff that you have to show them and make sure it's in place. And really, this comes down to the fact that applications have tons of dependencies. Years ago, you used to build an application that talked to a database, and that was pretty much it. It's not really that way anymore. Now, pretty much any modern application that's doing much is going to need a lot of services. You're going to need databases, you're going to need caching, you're going to need logging, you're going to need storage for files, you're going to need the ability to monitor all your logging, you're going to need the ability to search. And if you're in a traditional data center environment, every single one of those is an entire set of services and infrastructure that you're going to have to build that you're then going to have to be audited on. The nice thing about AWS is all of those services that you can utilize that Amazon provides are entirely handled by Amazon, and the requirements are entirely handled by them as well. So you start looking at it, your scope shrinks like 10 times if you properly utilize Amazon resources. When you start looking at this, and really what we did is we designed for PCI. It's something that we thought about from the very beginning. We had the luxury of building something that we knew had to be PCI compliant, so we planned for PCI before we wrote a single line of code. But what I would suggest is throughout kind of your entire development cycle, you make PCI a priority. So what we did is traditionally, as I said earlier, you have to have policy. And most people go about that by writing like 89 Word files that they then send to their auditors. It's not really how we go about it, because that's a lot of work for your auditors to have to deal with. So in the very beginning, before we built our application, we built an application to manage PCI. So we built an application, and we put all of the PCI requirements in there. And then we used essentially Markdown to establish these relationships to say that this requirement is handled by this section of our policy, which makes it really simple for your auditors, because as they're auditing you, they can see every single PCI requirement, click on it, and then see exactly which policy addresses that. And that's kind of why we can get through this in about a day and a half, because they're not having to spend massive time combing through all of these Word files. And then the next part about this is PCI is you spend a lot of time on it, but it's really the baseline for the security that you should do. It doesn't cover your application that well. It's really about infrastructure. And at the end of the day, when people get hacked, they get hacked through their application. Infrastructure hacks kind of went away like 10 years ago when people started not exposing SSH to the internet. So the DSS isn't going to protect you, and that's kind of why you really want to think about if you want to do this, because you're going to focus on things that really aren't the problem that's going to cause the pain for you. So kind of what we did, and this isn't really a representation of what we had today. This was when we first started building this, when we were trying to envision how do we build this architecture that lets us best utilize AWS and also will really help us from a PCI side. And it really comes down to taking the business portions of your code and wrapping them into services to ensure that your services essentially have only the AWS IAM permissions they need to do their job. If you build a traditional application, you end up with mass quantities of logic on one server, and you can't actually build IAM permissions that make sure that this set of code can only access this network resource. So we kind of went the SOA direction. I won't get too much into SOA because everyone already knows what that is. But it has a lot to do with PCI and making this easier. The less coupled you make all of this, the more granular you can get with your security. You can make sure that your network resources have security groups that ensures this very small chunk of code that handles encryption can only talk to these 3 things that have to do with encryption. It really lets us control the path of our card data. We make sure the less lines of code that touch cards, the happier we are, because it's easier for us to look at later and feel comfortable with. So I'm going to get a little bit now into how you can meet these PCI requirements on AWS, some tools that you can use. And like I said, a lot of this is Linux focused, but you could kind of do it on both sides. It's funny, though, because the most important thing if you're utilizing AWS is that you protect your AWS account. If someone gets into your AWS console, you pretty much can throw security out the door at that point. So you really have to understand IAM. You really have to feel comfortable with the rather confusing JSON rules that define permissions. And you really have to protect your root account. So our root AWS account we've used like twice. and that was to make our account and create our additional IAM users. Then you're going to take that, ensure you have MFA on that, and we make sure that we split that MFA and the password into separate safety deposit boxes, separate banks, and ensure that there's not one employee that could ever access the root AWS account by themselves. Once you protect the root AWS account, then IAM allows you to be very granular with your permissions and ensure that you have a good audit trail as to who does what. But until you do that, you never really know. A lot of the examples I'm going to give here are open source. Pretty much all of the security tools I'm going to give are open source. There's various reasons for that, but the biggest reason is because it's what we're most comfortable with. We've worked with open source technology, or all of us, for our whole career, so it's what we're going to work with. And as I said earlier, we kind of bet our business on security, so we feel a lot more comfortable knowing that we're using something that the world has reviewed. I've looked at a lot of the closed source security solutions, and what bothers me the most, especially in the cloud about them, is most of them at the end of the day require you install some agent on your servers and give them root access, and then those agents collect data from your servers and send them somewhere. That's not something we're really that comfortable with, so we don't utilize anything that would need root access that we can't code review. We're really particular about this. Almost every software package that we use, we watch all of the updates they do. We look at all of their commits, and we make sure that we're comfortable with the technology that we're using and the way that they have built it. I'll probably say this like 6 times, but the less EC2 you use, the easier this is going to be. And the best part about this is every single year Amazon makes this easier. Every year I come here and they spit out like 4 services that reduces our EC2 usage to where at this point, we don't have a lot left other than the real core of our business logic, which is nice. Years ago, you had lots of infrastructure dealing with DNS and all this stuff that's in your EC2 environment that you would get audited on. Now you really don't have to do that, which makes it a lot easier. But we use EC2 because it gives us the flexibility that we need, because there's not a service for everything, and you have to build an application, and that's pretty much going to run on EC2. So just realize that flexibility is going to bring responsibility, and I've laid out pretty much everything here you have to solve if you use EC2. If you want to be level 1, every one of those things you're going to have to explain to an auditor how you're going to accomplish. So I'll kind of work through every one of those and ways that you can do that. And we'll start with change control. And I won't spend a lot of time on this because there's like 40 tools now for this, but really what you want to make sure is that no one is doing manual changes. No one should be logging into production instances and doing things. We don't ever log into production instances because our whole process is built around that never happening. And that's, to us, a really suspicious activity. If someone logs into production instances, it's going to kick off IDS alerts everywhere, and then we're going to have to explain that later. So we made sure we built a workflow that makes sure that ensures that never happens. So the rules that we kind of established early on, at this point, probably about 3 years ago when we were looking at this, is we would never make changes to production instances. Every change we made, it didn't matter if it was deploying code, if it was changing one line in a config file, if it was installing a new update or a package to comply with some new security issue that just came out, we will always make new instances. The nice part about this is it lets you be really granular with the security around your production instances. We don't have a production EC2 instance that can talk to maybe 1 or 2 network resources because we've done everything we can to assemble it beforehand to really make sure that our production instances can't do things that they shouldn't be able to do, which is going to buy you a lot if you did ever have some code vulnerability in your application because it's going to be very difficult for people to do things. The way that we accomplish this is we created this, what we call a stage concept, and a lot of you probably already do this. And the first thing that we do is we start with the distribution AMI. So you find a distribution out there you want to use, and ultimately that's where you're going to have to start. So we start with our distribution of choice. We launch that. We ensure we install all of the system updates. And then we use Puppet a lot. I don't know why anymore. I'd probably use Chef if we were rebuilding, but we use a lot of Puppet. So we apply all the Puppet manifests that assemble the server and configure it for its role. And we stop right there and we create the AMI, because at that point, we know it's updated, we know it's ready to go, but we didn't install the code on it yet, because this process is really slow. This takes like 25 minutes, and we don't want to wait 25 minutes to deploy. So we create an AMI right now, and that AMI is what we're going to use when we're preparing instances for production. So you can script that, you can build those every night, you can build instances that have all of the latest packages, everything you need for them to run in production. And that way, when you need to deploy, it's already there. So we take that base AMI that we built off the distribution with the updates, with everything it needs to do its job. We launch it, we add our code to it, we test our code, and we create the AMI that is then ready for production. Once the production AMI is ready, it's pretty simple. We launch it, it goes into a load balancer. Going through this process has a lot of value to it. We change the rules for our IDS for each stage. That way, when we're deploying code, we're not triggering our RDS on the fact that the code is changing. We can deploy our code, ensure that the code is legit, matches the checksums that we expect, but isn't going to send alerts. And at every layer of these stages, we change our network permissions, we change every layer of permissions to make sure that each stage can only do exactly what it can do. So change control, just talked about that, and that's something that people pretty well have figured out now. Patch management's a really big deal for the PCI DSS. You ultimately have to create policies in your organization to map patches to priorities. So you can say, a high-level package here needs to be installed within 7 days, according to the DSS or whatever it is for us. For us, it's basically a day if a high-level security vulnerability comes out. So you have to figure out how you're going to do these patches, and because patching is generally considered really painful, we made sure our entire workflow naturally supports patches. If we're deploying new code, we've already ensured we've installed the latest packages because of our whole stage system. Since our normal workflow installs patches really isn't that painful for us. And so if you get patches figured out, then you just have to get to the technical parts that will continue. So VPN, there's a lot of requirements in the PCI DSS that are going to change how you set up your VPN server. And the VPN is ultimately going to provide you with the way that you get into your VPC to manage your resources. PCI is very specific about requiring multi-factor authentication. And if you attack that at the VPN layer, then you don't have to figure out how to attack that at every single other layer, which gets really hard depending on which technology stacks you're using. So what I would recommend is OpenVPN plus OpenLDAP plus dual security. Dual security is the only commercial solution I'll mention here. We have no vested interest in them. It's just they have a really great OpenVPN implementation if you need to do multi-factor authentication on it. So OpenVPN, if you're worried about implementing the best VPN or security, the vast majority of commercial VPN solutions that you'll see people selling you are actually built on OpenVPN. So you can feel pretty comfortable with that. It's a SSL-based VPN. It's not IPsec, so it's going to work a little differently, but it works pretty well. And really, at the end of the day, you're just going to create an EC2 instance or different EC2 instances in different availability zones depending on your availability requirements. So once you get OpenVPN, you have your VPN server, but the problem with that is it doesn't have a user database, nor is it compliant with the vast list of requirements with password complexity, history, failed login attempts, making sure you're locking users when they need to be locked. When I first started looking at the PCI DSS and how we would meet these requirements on our VPN server, I was slightly frustrated because the PCI DSS is pretty much a direct copy and paste from Active Directory. So if you use Active Directory, it's great because they just copy and pasted like all the checkboxes. But if you don't use Active Directory, it takes a little bit of work to figure out how to do this. And we initially used Active Directory, and it kind of burned my soul, but we did it so that we could just get past this. Eventually, we figured out you can meet all of these requirements with OpenVPN and OpenLDAP. There's a library for OpenLDAP available called the Password Checker Library. So OpenVPN plus OpenLDAP will give you your VPN server plus your user database plus all of the requirement, I think it's 8 requirements that you need to do for passwords. Then you just need to plug multi-factor authentication into it. I like dual security mostly because they work with OpenVPN and it plugs in nicely. If you have a small team, less than 10, you won't pay anything. If you have a larger team, you'll pay basically nothing compared to what you would pay for a commercial VPN solution. So once you get past VPN, then you really start looking at your instances and all of the things that have to be installed on an EC2 instance to comply with PCI. And file integrity and intrusion detection systems is part of that, and that can be a little bit tricky. So you can do file integrity monitoring and a host-based intrusion detection system really easily. There's not a lot to it. OS-sec is what I like, and once again, a lot of commercial solutions use OS-sec. Trend Micro backs OS-sec. They'll keep it free and open source. They say that. And it's just a software package you're going to install on all of your EC2 instances. It's going to analyze network traffic. It's going to monitor all of your logs to look for things that are suspicious that will occur. And we've tweaked ours to be really paranoid, to look in the logs to see things that are different from our workflow. So that'll get you pretty close, but it's still not a network intrusion detection system, which you're going to need to comply with PCI. So for the network intrusion detection system, we're pretty big fans of Snort. As I've said with all of these previous systems, pretty much all the commercial solutions use Snort as well. So it's a pretty good option if you can figure out how to set it all up. Snort does support the ability to log all of its events that it detects that are suspicious to a MySQL database. And if you throw that on RDS, then you don't have to worry about managing a MySQL server and the PCI requirements there. The problem, though, with network-based IDS is in a traditional network, you go into your Cisco switches, you configure ports to mirror all of your traffic to your intrusion detection system, and there's really no way to do that on AWS. So you can utilize daemon tools plus OpenVPN to kind of accomplish this. The way this ends up looking is you have an EC2 instance, and with an EC2 instance, you get an ETH0 interface that plugs you into your VPC. The next thing is you can use daemon tools to create this tap0 interface that's going to mirror all of the traffic on the ETH0 interface. And with that mirrored traffic, you can then send that to your Snort IDS system. We wrap all of that mirrored traffic into a little OpenVPN network on every server to ensure that it's properly encrypted as it flows past our VPC. So basically, daemon tools will mirror it, OpenVPN can encrypt it, and then that's going to flow to your Snort instance. And you can use multiple Snort instances depending on what you're trying to do with availability and so forth. Once you've done that, the next trick is to figure out how do you actually manage like 20,000 IDS alerts as you're tweaking it. And there's this solution called Snorby out there. It's a Rails app. It'll just hook into the Snort database that you're running on RDS and then can provide you with a user interface, and you can tweak your rules from there. The thing about an intrusion detection system is if you don't take it really seriously, you can implement it and check off the PCI requirements, but you really have to try to tweak it to how your business works, how your servers work, how your workflow works, so that you're not getting a ridiculous number of alerts that you can't manage. So that way, when an actual attack doesn't happen, you're not a target that ignored it because you're used to all of these other ones. So you've finished the intrusion detection, file integrity. The PCI DSS is really clear that you have to implement antivirus. It doesn't matter if you're running on a Linux server, and it can be frustrating to do that. The way we look at antivirus is, we'll implement it, we'll do it, but we don't count on it because we can pretty much count on the fact that if someone does infiltrate us, it's going to be through our application, and they're going to write their own code they're going to put on our server, and there's absolutely no way that an antivirus database is going to detect that. But you got to implement it. So you implement it. ClamAV works great. It's open source. SourceFire Inc., I think, is the one that owns it right now. You can use FreshClam, which is basically a daemon that ClamAV provides to ensure that you're updated in your definitions. If you're doing that, I would suggest you try to locally mirror your definitions so that you don't have to allow your production instances to reach out to the internet to grab antivirus definitions, since we make sure we don't have a production instance that can touch the internet. So you always got to kind of figure out how you're going to update that and handle that. And then you can configure that to alert to anything. In our case, we like CloudWatch. The next part that used to be really painful that I didn't like talking about was centralized logging, because you have to, all of this stuff you implement, the DSS is pretty clear that the logs have to go to one place. And when you're running on AWS, it's really tempting to use the commercially available logging solutions that people sell. And we've been down that road and we've done it, but most of them can't produce a PCI report on compliance. So then you're trying to explain to your auditors why you send your most critical logs to someone that isn't PCI compliant. And we went through that. We actually modified our syslog to be very aggressive with filtering to ensure card numbers couldn't get through it and things like that. And you can accomplish that if that's what you want to do, but it feels really dirty. The nice thing is Amazon released the ability to do logging into CloudWatch, which is something we've migrated to. It's not very feature-rich right now, but I'm sure that'll change. And if you do use CloudWatch for that, you're going to run an agent on all of your servers. You configure that to monitor all of the logs that you consider important, which is basically all of them. So you really, if you install CloudWatch and you're just watching syslog on a Linux server, depending on your distribution, there's a lot of stuff you're going to be missing. So you really need someone that understands security and how the distribution works to tell you all of the log files that are going to be relevant. So the next part about this that's pretty challenging, or has been pretty challenging to handle on AWS, is how you protect your keys. So in the AWS environment, you have everyone out there is doing everything they can to deploy servers from code. And very few people are really thinking through the consequences of that, because you have configuration files with RDS credentials, you have configuration files with API keys for partners, you have private keys for your SSL certificates, and then if you're doing credit cards, you probably have encryption keys that encrypt credit cards. And you have to figure out, how do you handle this and keep all of that important stuff out of your GitHub account? And not a lot of people do, but if you take this seriously, you really need to figure that out. When we were looking at this a few years ago, Cloud HSM didn't exist. Key Management Service, I think that's what it's called, didn't exist. So we built our own key service that ran on EC2 that pretty much works just like the one Amazon released yesterday. And the one Amazon released yesterday is better than ours. It handles availability much better than ours does, high availability and things like that. So we're already working to migrate towards that, and I've been playing with it. The nice thing about the AWS Key Management Service is it supports key rotation itself. So if you look at the DSS, one of the requirements is really clear to make sure that you're rotating your keys. And then traditionally, it's a really painful, scary operation, because if you mess it up, you might lose all the credit cards you were securing in the first place. The other nice thing about the Key Management Service is it provides a very clear route, a very clear description on CloudTrail about what was being accessed. And if you utilize it properly, you'll know that this encryption key was used to access this record that we were securing at this moment in time by this resource. And I'll get into kind of how you do that. So to encrypt a record with AWS Key Management Service, first thing you need to do is create a master key. There's different ways to go about this, but I would recommend that you create a master key that's unique to each data record. I think the pricing's like $1 a month a key or something, so there's not a reason to not do that. So create a master key that has to do with your configuration files, create one that has to do with protecting your SSL keys, and so forth. The purpose of the master key, however, though, isn't to really encrypt your data. It's to create keys that you then use to encrypt your data. So you're not sending your data to the AWS key management service to have them encrypt it. You're using that to get encryption keys that then you can then use to encrypt your data in whatever method you would feel comfortable with. Once you get that key master created, or the master key, you're then going to create the data encryption keys that you're actually going to use to encrypt your data. So you'll pass to the AWS SDK the identifiers for the master key that you want to use, and you'll pass an encryption context. And the encryption context value, the real power in that is to make sure that you're kind of explaining what you're encrypting, so that way when you're auditing this through CloudTrail, you can see that this key is related to this record that I'm encrypting. So you'll want to pass some kind of metadata in your application, maybe a customer ID, a card ID. Don't use the card number as the encryption context. That wouldn't make a lot of sense. So you'll create this encryption context. You'll send this. You'll get this data encryption key. There's absolutely no reason to not create a new encryption key for every single resource that you encrypt. You're not charged for data encryption keys, so you might as well go for it. So you create this data encryption key. Once you create that, they're going to return kind of two main important things to you. They're going to return the ciphertext, and they're going to return the plain text string, as they call it. And the plain text string is actually the encryption key that you should use in whatever algorithm you like to do encryption in. You're going to encrypt your data. You're going to store the ciphertext, because if you don't, there's no way to decrypt it. And you're never going to store the plain text encryption key. So you've done all this encryption, and now you need to decrypt your data. And if you did this all right, hopefully you can do it. So to decrypt it, you have to have that ciphertext that they gave you earlier. You're going to pass them that ciphertext and a couple other fields. Once you've done that, they'll return that same encryption key to you that you can then use to decrypt your data. It's pretty much the same model of what we built, but like I said, they solved the availability issue between availability zones and stuff like that we hadn't quite worked through. I can't imagine why you wouldn't utilize this right now. So I've looked closely at this. Cloud HSM is also an option and might make sense for some of you. It's drastically more expensive, though, so I would lean towards this unless there's an exact reason that you would want to use Cloud HSM. Some other best practices with this is the nice thing about using a different master encryption key for each resource is it makes it really easy for you to be granular with security. You can do this kind of with IAM if you don't do that. But from an auditor perspective, if you're dealing with an audit, I can pretty much guarantee you if you're using one master encryption key across everything you encrypt, they're going to be really unhappy. So generate a different master encryption key for every resource. Make sure you enable the option to have AWS rotate that key. There's no pain to you to have them rotate that key. You don't have to deal with rotation. It's just a checkbox that makes life much better for you. And then, like I said earlier, make sure that you're using a unique key for every record. So, you look at all this, you look at what it's going to take to meet PCI, and it might not sound too bad, but at the end of the day, storing a credit card number, touching a credit card number, it's a giant liability. And I would be really careful to make sure it's worth it. I would make sure that the benefit of touching a credit card number is worth it. If you're not in the business of handling credit cards or storing credit cards, I can't fathom why you would decide to do it. And there's a lot of options out there. We're one of them that can ensure that you don't have to deal with the credit card number, and your customers will never know the difference. The liability, though, of PCI is kind of funny. It extends by far beyond the possibility of losing a cardholder number, which is bad already. But even if you do everything right, even if you never lose a cardholder number, it's a very heavy process on your business. The DSS will hold you back pretty much everywhere. Deploying is harder. The paperwork that you need is harder. So if it's not something that you make money off of, I would be very careful about doing it. But if you do decide to do it, just remember the DSS is just a baseline. It's the start. It's not going to protect your application. It does a very poor job of protecting your application. There's like one requirement in there to maybe scan your application, and that's about it. And And your application is where you're going to get hacked. So just because you're PCI compliant doesn't mean you don't have things to worry about anymore. So I would really look at your application always and don't think so much about just ensuring that I'm DSS compliant and I'm OK. And the set of tools I described, OpenVPN, OpenLDAP, Dual, Snort, Clam, it's just a start. That's things you can use if you want to build a compliant environment today. But I would reach by far beyond that if that's what you're doing. And I would make sure that you're never in a state with your organization to where you feel like you're secure and you don't need to try anymore, because that's not really a good strategy. It's an effort you always need someone working on, is how can we make sure we're building more secure systems. So that's kind of what I got. That's the end. So if anyone has any questions, you can get a hold of me at Twitter @JesseAngel, or you can email me. If you have PCI questions about how you can accomplish PCI in your organization, I'd be glad to help you with that. We don't make any money off that, but I'll help you build what we have. But at the end of the day, there's a lot of pain in that, and we have the technology to ensure you don't actually have to touch credit card numbers. You don't have to worry about any of this, and we'd love to help you with that as well. Thanks for your time.